Okay, so today's notes on our lesson 4.5, solving quadratic equations by graphing. Okay, so I guess some review things is the x-intercepts of a graph are the solutions of the equation, right? Which we already know. So this solutions means x-intercepts, which can also be called roots, zeros, right, and solutions. All of them mean x-intercepts, right? Okay, so you have three different possibilities, which this is like a mini algebra 1 review, right? You can have one real solution. So the vertex would be your only point that is intersecting with the x-axis. So one real solution. Then you can also have two real solutions, right? Which means that you have two ordered pairs, two separate ordered pairs across the x-axis, or no real solutions. Now, in Algebra 1, you would pretty much be done. If you knew that there was no real solutions, that's really all that mattered, and you're like, oh, okay, no real solutions. But in Algebra 2, we're going to be discovering what the solutions would look like, okay? Which means they would be complex numbers, which we will talk about further a few lessons down the road, okay? So we're gonna solve the following examples by graphing. So y'all already know how I feel about making rough sketches, right? So we're gonna make a quick table just for the first few examples so that you can see that you can get something going, right? So we're gonna have x and then f of x, which we know is y, right? So for, well, what's thing that we do know, right? So then here's my rough sketch. One thing that I know is that this, because it's in standard form, I know this is my y-intercept. And I know because my a is a positive 1, I know it's going to open up. So -2, -4, -6, -8. Ooh. So let's do a better. So let's do 2, 4, 6, 8, 10. So here's -10. This is going to be my y-intercept, right? And I know it's going to open up. So it's going to look, you know, something like this. I don't know. All right. So we can kind of get an idea of what numbers we should do, right? So let's go on ahead and do some type of negative number because we're probably going to have something going on over here. So let's do -2. So we're going to have -2 squared minus 3 times -2 minus 10. What is that going to give us? Well, -2 squared. I have a calculator because I'm not about to do this. Okay, so -2 squared minus 3 times -2 minus 10. That gives me 0. Oh, that worked out nice. So let's make -2 here. So we have an x-intercept there. So then this is my y-intercept. So now let's do a +2 and see where that ends up at. So we're going to do +2 this time. That gives me -12. So at +2, we're at -12. So -10, 11, -12. So I have a dot right here. So I can see that I'm starting to approach my vertex, right? Which means that if I want to point somewhere on this side, oh, +2 was -12, and I put that in the calculator. So then we should probably pick a point, maybe like let's do 5. So we're gonna type it in again. Hit enter, and we get 0. So 2, 3, 4, I don't know, 5. So that would be another x-intercept. So this would be a rough sketch. I should have probably made it. I don't exactly know what the vertex is. This could have been my vertex. I mean, we could figure that out, right? We know how to do that. We would have done -b over 2a, right? And then plug that into the equation. So, which would have been at 1.5. So your vertex would actually should have been somewhere around here. Close enough. Anyway, that's a rough sketch. So you can always make your rough sketch just by grabbing some of your basics first, right? So we knew this was a y-intercept, and then I knew how to open up because this is a positive A. But you could always just find your key features and graph it that way. Anyway, the purpose of today's lesson is just so that you learn how to do it in the calculator, basically, okay? So we're gonna be using Desmos, and I actually make my Algebra 1 students use the Desmos that the Texas state allows on STAR Test. So I'm thinking if they allow this version of Desmos on the STAR Test, I don't see why you wouldn't be able to use it. So the web address is desmos.com/testing/Texas/graphing. So Desmos Texas STAR version. This is probably the closest thing that you can get to this calculator. And even then, I think this calculator might do a little more. But anyway, so if you want to get used to using something that's a little bit more reasonable for you to use, I'd probably use this instead. Okay, so we're going to graph this. F of x equals x squared minus 3x minus 10. Ta-da! And you can see, oops, you can see it looks pretty similar to what I drew. What do y'all think? Not too shabby, right? Anyway, so remember, the whole purpose is that we're trying to find the zeros of the function, which I happened to find, right, when I was working this out. And I know they're my zeros because my x-intercepts are going to be at x, comma, 0, right? My y value is always going to be 0, which is what happened here. So my x-intercepts are actually at -2 and 5. I just happened to pick the right numbers, you guys. I didn't do this on purpose. So -2 and 5, and we can see from this graph, when you go to it, -2 and 5. There's your x-intercepts, your solutions. Ta-da! Okay, so we're just gonna be doing this literally for like most of these examples, and a few of them I just might let you do it on your own. So for 2, anytime you're trying to find the solutions, here I didn't do that, right? I just made my own table and I got a rough sketch and I got lucky. But if you're going to be putting it in the calculator, we need to understand why it is that we have a 0. So 2x squared plus 5x plus 3. Why do we have a 0? Well, if you remember, g of x is function notation, right? And what is function notation? That just means that g of x is really just y. Let me move this real quick, right? That's really just y. And that came out kind of faded, but oh well. And what we just talked about, right, is that if we're looking for the x-intercepts, right, because we're looking for the solutions of a quadratic function, and that means we're looking for the x-intercepts, what do we know? We know that y is equal to 0. Well, let's talk about what y equal to 0 means. From the last a few lessons, you should remember, so let's write that again, right, y equals 0. From the last few lessons, you should have remembered us talking about Hoivaks, right? This is y equals 0, so I know that y equals 0 is a horizontal line. Well, this horizontal line is your x-axis, which is why we have that 0 here, because that's where y is. So we're replacing our y with 0 because we're telling this function, I want to know where does my x values intersect with this 0. So y equals 0 is really a representation of the x-axis. It is a horizontal line, right, that crosses at y equals 0. So from here, um, 2x squared plus 5x plus 3, okay? Okay, So for this one, I'm using the actual Desmos website, and here's why. First of all, why does it look like that? 2x squared, hold on. Interesting. Okay, anyway, so you're gonna notice that you can't do 0 there, right? Because it doesn't work in the Texas Star version. And the reason why is because it wants an actual function put in here. But if you know that your y has to equal 0, right? Do you see how this green line is your x-axis? So then now you have an intersection between your x-intercepts and the x-axis, because this x-axis is a horizontal line, and we know that horizontal lines are always going to be y equals a number, which this number we want it to be 0 because that's our x-axis. So what are my solutions? -1.5 and -1. So our solutions, right, our zeros are at -1.5, comma, -1. And we talked about class and how to write this down properly, right? Oh, sorry. You can also write them as ordered pairs, -1.5, 0, and at -1, 0. And you can also just tell me x equals -1.5 and x equals -1. So these are different forms where you can show me the correct answer, right? With curly brackets, in ordered pair separated, and then x equals each individual x-intercept. So number 3, again, we have h of x equals x squared minus 8x plus 16. So remember, h of x is really just y equals x squared minus 8x plus 16. So what are we finding for? When it's asking for what are the solutions of the following graph, that really means that we want x comma 0, and we know y is equal to 0. So we're just looking for where does this graph cross the x-axis, right? So we want to know where is it crossing here. This line right here that I'm darkening with my pencil, this is y equals 0. So that's why we put a 0 right here. So 0 equals, in case y'all didn't know, why do we always use 0 here? And why does it have to be 0? Because we're using the x-axis, right? But obviously, if we kind of know that, right, we don't always have to put this green line. Like, we kind of just already know, hey, here's my x-intercepts right there, right? So this next one is going to be x squared minus 8x plus 16. Now, what you're going to notice is, where did your graph go? So we're going to zoom out because it's there somewhere. Oh, there it is. So let's zoom in, click on the graph, and you're going to see that it has exactly one x-intercept, right, at 4, 0. So your graph looks something like this. Oh, sorry, you can't see what I'm saying. Okay, and it only had one intercept at 4, 0. So the only solution is at x equals 4, or you can say 4 comma 0, or you can just put curly brackets 4, close bracket. Okay, next, you're going to notice that these are out of order, and it's okay. That's fine. You can reorganize it if you want to. What's really important is that you need to make sure that this is 0, must be 0. If it's not 0, then you need to use inverse operations to move it to the other side, okay? Again, you can leave it like that, but if you're gonna rearrange it, make sure it's in ax squared plus bx plus c form, and you have to carry the sign, right? So carry the sign if you're gonna reorder it. So that means I want this x squared first, but it has a minus in front of it, so it's negative x squared. Then I want this positive 6x, so I'm gonna put plus 6x. Then the constant minus 9 equals 0. So then you can graph that. So then you would have y equals 6x minus 9, or sorry, I was typing the original. Well, yeah, I guess it doesn't matter, x squared. Okay, so it's still gonna graph it. And you can see again that it has one x-intercept at 3, 0. So that's the only solution. All right, 5 and 6, same thing. You're just gonna type, okay, so y'all get the point? Okay, you're literally just gonna type them. All right. I'm waiting for one. I'm waiting for a specific one. So x squared minus 3x. All of these have x-intercepts. So let's zoom out. Let's turn off this one because we already did that one. And we can see its x-intercepts. There's one at 0, 0, and 3, 0. So I did a really bad habit right here, right? I was supposed to type y equals, and yes, it's still gonna work sometimes, but just make sure you don't do that. So be better than me, right? So you have 0, 0, and what was the other one? 3, 0. Obviously, this is a lot easier than doing it by hand, but y'all can do that one on your own because it's gonna come out. So let's keep going. So, oh, you can see the orange. It's okay. So the next one would be x squared plus 6x plus 7. Okay. All right, so you have this. And then again, you would just type in, or not type in, you just go here. Okay, now this is where graphing is not so convenient, okay? When your x-intercepts aren't pretty, you're gonna get some type of decimal, right? So you're gonna get negative 4.414 comma 0. And then you're gonna get negative 1.586. More than likely, your answer choices or your response is not going to be in decimals. So, I mean, we could try typing it in, right? Negative 4.414 and see if it'll give us a pretty fraction. That's not pretty, okay? So, this would be an example of where doing it by hand would be better. By hand or doing it manually, right, would be better. And we will talk about those methods later on in a future lesson, okay? So this one is definitely to be continued, okay? So this is in, so again, this is an example of where just putting it in decimals is not the best idea because your answer choices are probably not gonna look like that. They're gonna look in a different format, which again, we're gonna do later, okay? So I just wanna make sure I reiterate of when this would be a good idea, or you could just put it in decimals, and when you can. So our next one, 2 times w squared. Well, let me do w squared minus 2w equals 5. Now, remember, I'm using the star version, right? So it's not gonna let you do this. You have to have it set to equal. If you did it on here, it would let you, okay? But what did we say earlier? So earlier we said that it has to be equal to 0, right? Because that's where your x-intercepts happen, at the horizontal line of the x-axis, which is why that 0 is important. So we would actually want to move that over. So we're going to subtract 5 to both sides. So you would have 2 times w squared minus 2w minus 5 equals 0. Now, could you distribute and could you simplify and write it in proper vertex form? Yes, you could, right? But because we're using graphing, we can just go on ahead and graph it. So because I have a 0, right, then I know I can just hit y equals 2 times x squared minus 2x parentheses minus 5. So let's turn this one off. Oh, notice I used x's instead of w's. It's just a variable. Like, we know it's the same thing, right? Okay, so right here, again, we have not so pretty x-intercepts. So this is when graphing is not the best idea. So we could still write that down, right? Comma 0. So 2.871. All right. And I'm still looking for a very specific example. Okay. So then this one we have, this is the example I was looking for. Okay. So when I type this next problem in, right, y equals, this is what we get. Now, in the beginning of the notes, we said, right, if it's not crossing the x-axis, it's no real solution, right? So for this problem, right, x squared plus 4x plus 8, we have no real solutions. In algebra 1, this would be your answer and you would be done, okay? But in algebra 2, we're gonna go deeper into solutions, right, in complex numbers. So I just want you to know that this would not be it, right? So you would have a graph and it would look something like this. This is what we got, right? I'm just drawing a rough sketch. It's not crossing anywhere. So for this problem, you would have to use the quadratic formula. So make sure you write that on there so that you know what to look forward to when we get to it. So which you should have an idea of what this is from algebra 1, right? You should have used the quadratic formula in algebra 1. This formula will help you find those complex solutions or imaginary solutions, imaginary numbers, whatever you want to call it, okay? So similar with this one, right? Just like this one, it has to be set equal to 0 because this 0 is telling me that I want to know where this quadratic function is crossing the x-axis. So in order for this to be proper, we would have to add 1 to both sides. So you're going to have 5x squared plus 2x plus 1. Now that's set equal to 0. So now this is telling me I want this quadratic function. I want to know where it equals 0 because this is the x-axis and I want to know that, the horizontal line, right? Poivox, we talked about that. Okay, so y'all can do that on your own. A rectangular garden measuring 12 meters by 16 meters is to have a walkway installed around it with a width of X meters. Together, the walkway and the garden should have an area of 396 meters squared. Find the width of the walkway. Okay, so let's look at what we have because this can be a little wanky. So a rectangular garden measuring 12 meters by 16 meters, that's right here, is to have a walkway installed around it with a width of X, right? Together, the walkway and the garden should have, so together, so inclusive, together the walkway and the garden should have an area of 396 meters squared. So it's almost telling me this middle part is just there, right? So the area of this entire thing is 396. Find the width of the walkway. Okay, so I know this is 16, right? Which we could say the length. Okay, and you can see that my width is 12, my length is 16. Okay, so we know that this entire area is 396 meters squared, which includes my 16 and my X, right? So those dimensions. So what do we have? From here to here, we have X. From here to here, it's another x. So how many x's do we have? 2. And we know from here to here is 16. So this length, right, the length of the larger, I misspelled length, the length of the larger is gonna be 2x plus 16. So what is my width going to be? Okay, so my width, let's look at it. So the small one is 12, and we can see that we have x from here to here. So we have x from here to here, and we can see we have x from there to there. And we know this part is 12. So again, we have 2x plus 12. Okay, so how does this help me? Well, how do we find the area of a space, right? So area equals length times width, which means we're gonna have this area is gonna be my length, which is 2x plus 16 times 2x plus 12. Okay, well, what now? We know the area. This is my area. So this area needs to be 396 meters squared when I multiply my length and my width. What I want to know is, what is the width of the walkway? So pretty much the width of the walkway is this chunk right here, right? So I want to know what is x. All right. So you can see, hopefully you see, that this is a quadratic function because it's in intercept form, right? So there's a few ways you can look at it, okay? If we're gonna use decimals to help us, yes, you could do this by hand, right? We would have to, now remember, if I wanted to do this by hand, this would have to be 0 equals blah, blah, blah. This is such a big number that honestly, I would probably use decimals for this because the goal here is that you understand what's happening in the context of a problem, not so much computation, okay? So what I do know is that to find my solutions, right, I know that this has to be set equal to 0. So what are we gonna do with this 396? Well, we're gonna subtract it. So 0 equals 2x plus 16 times 2x plus 12 minus 396. Now, here's the beautiful part about being able to graph on decimals is that if you are just trying to get your answer, right, do I need to do my little box method and convert it to standard 4 completely? No, I mean, you could, but you don't have to. So you can see that I typed it in here already, right? So 2x plus 16 and then times the quantity of 2x plus 12, then subtract 396. So when we turn that function on, you can see that there's 2x intercepts at -17 and +3. So this is where we have to think in realistically in the context of the problem. So that means that we have two solutions, x equals -17, and we have x equals 3. So according to this, there's two numbers that fulfill this value of x, and that's -17 and 3. Can a width of a walkway be -17 meters? Right? Because that's what we're dealing with, meters. No, that's unrealistic. This is not realistic in context of the problem. So your only solution is going to be 3. So the width of, find the width of the walkway. I wonder if it means this entire width, right? So I guess it depends on how you read the problem, because the width, I don't know if it means X or if it means literally all of this. So we're gonna answer both, okay? So the width of this walkway, the width of the walkway is 3. I'm assuming that's what it's asking for, because this is also the width-ish. No, the inside. I think it's asking for this little x, okay? Just FYI, because that would be the whole purpose, right? To throw out this -17 because it's not It doesn't make sense with what we're talking about. So I think that would be the point of this. Now, if I did want to figure out the dimensions of the walkway around the garden, then I would just plug that in, right? So 3 would be 2 times 3, which is 16. I mean, sorry, 6. And then 6 plus 16 would be 22. So this right here is 22, just for fun. And then this part right here, again, that would be 16, or, oh, I put it for here. So sorry, this right here is 22. Which means this one would be 2 times 3 is 6, plus 12 would be 18. So this would be 18. There we go. Okay. All right. You have a 500-foot roll of fencing and a large field. You want to construct a rectangular playground area. So rectangular playground area. So I know what a rectangle is. So I'm going to draw a rectangle. What are the dimensions of the largest playground? What is the area? Oh, okay. So you have a 500-foot roll of fencing and a large field. You want to construct a rectangular playground area. So we have 500, and you want to construct a rectangular playground area. What are the dimensions of the largest playground? So dimensions of largest playground. What is its area? Okay, so this, I know one thing. We know that area is length times width. That's one thing we know right now. Okay, so this last problem is really, really tricky. Okay, just bear with me, okay? So try to follow along the best you can. Yeah, just try to follow along the best you can, okay? So, because this incorporates like a lot of moving parts. So we know we have a 500-foot roll of fencing, right? And a large field. And you want to construct a rectangular playground area. What are the dimensions of the largest playground? What is the area? Okay, so we already said area equals length times width. So we know this is going to be important, right? So we have, so I'm going to change it to terms of X and Y, just because that's what we're used to dealing with, right? I guess we can do that at the end. No. So area equals X times Y. So we're going to make my length is X. So X equals length. And then we're going to make my Y width. All right. Now, what we know is that we only have 500 foot to do this fencing with. So what does it mean? Well, what does a fence do? A fence goes around a rectangular area, right? So if a fence goes around this rectangular area, what is that talking about, right? So that's actually talking about perimeter, right? So we know my perimeter has to be 500, okay? So is everyone following along right now, right? My perimeter has to be 500 feet. That's non-negotiable. We don't have more fencing than that, and we can't use any less than that. It has to be exactly 500. Okay, so then what does that mean? Well, what is perimeter and how do we find it? Well, we know what perimeter is. Perimeter is double your length plus your width, right? We know where that comes from. We have length, width, length, width. So we have length plus width plus length plus width, which really just means we have 2 of length and width, okay? We all know where that comes from, good. Now, we know our perimeter. Well, our perimeter is gonna be 500 of 2 times X plus Y. Well, remember, I made X my length and my Y is my width, okay? So right now we have this equation and X is Y is here. So what we wanna know is well, I wanna know one length. Can I get down to one length or a width, okay? So we're gonna manipulate this equation and put it in terms of length or width. Again, it doesn't really matter which variable you choose. And because we're used to solving for Y, I'm just gonna go on ahead and do Y, okay? So we end up with 500 equals 2X plus 2Y, right? And if I wanna isolate my Y, that means I need to remove my 2X. So subtract 2X from both sides. So you're gonna have 500 minus 2X equals 2Y. divide everything by 2, and I'm going to go on ahead and put y on the left. So y equals 500 divided by 2 is 250. Negative 2 divided by 2 is negative 1x. So what does that mean? I just said that my y is my width. So my width is going to equal 250 minus x. Okay? So I'm just grabbing what I know and doing this. Okay? So if this is my width is going to be 250 minus whatever I choose my length to be, correct? Now, it's asking what you want to construct a rectangular playground area. What are the dimensions of the largest playground? So I want the area to be as big as it can be with only using 500 foot. This is where we would use our area formula now, okay? So we know what y is gonna be, right? We know that area is length times width, which is x and y. This is going to be my width, right? Which is my y. So area is going to be x times 250 minus x, right? That's how I find the area, length times width. And I found what my length should be, okay? So we're gonna have area equals, I'm just gonna distribute and make it a little prettier. So we're gonna have 250x minus x squared. So what type of function is this? This is a quadratic function, okay? So what do we know? All we know is that this is my length and my width. I made it prettier just because you didn't have to. You could have just typed it in like this in your calculator, right? But I want to know, where is my greatest area? So remember, this is my area, right? Which is the output, which is the outcome. So if I have a negative parabola, where am I going to find, so this is area, and what comes out of it, and this is my length and my width, right? So this is what I'm multiplying together. And what's my area gonna be? So what do we have here? So when we graph it in Desmos, right? So I went on ahead and typed 250, sorry. Why isn't it? Okay, so I typed it in the originals just so that you can see that I just wanted to make it prettier because I felt like it, right? But you could have typed it like this, 250 minus x times x, and that's exactly what we have here. Okay, so from there, because I want to maximize my area, I'm gonna look for the maximum, which is at 125, comma, 15,625. So what does that mean? Okay, so remember, this is your output, right? And x was my input, which is length. And this is my area, which is what came out of it when I put these functions together, right? So if my length is 125, right? Or my length is 125, then that means my width is 125. How do I know that? Well, 125 times 4 is 500, right? So that my area, my perimeter is fulfilled. And that area of this playground is going to be 15,625 square feet. So the dimensions is going to be a 125 by 125 feet. And the area, right, because we're looking at the maximum, is going to be 15,625 square feet. Like I said, I know this last question was a little bit out there. Hopefully you followed along pretty decently. All right. There you go.